video, I shall explain the International System of Units. This is our very first class in physics, and this is the first topic that you must understand for you to understand physics, even as we are doing other topics. Now, before we even get into the details of the International System of Units, let us look at its back history. So, a long time ago, before these units were discovered, they were there, but they were just discovered, but something is always there, but it's just discovered. So you would find that people in different countries would use different units of measurement to find out their physical quantities. For example, let's talk about let's look at something like measurement of length. Other people would use feet, other people would use centimeters. In other countries, they would use inches, and so on and so forth. So that brought about a lot of confusion, and we needed one system of measurements that would work throughout the world. And so the International System of Units was then introduced. So the International System of Units, represented as SI unit, just talks about the international units that are accepted in all parts of the country as standard units of measurement. So you would find that if you are measuring time, it's measured in seconds, minutes, or hours in all parts of the world. When you look at something like length, you would find that it's measured in centimeters in all parts of the world. That also relates to something like currency. If you're looking at currency, we use different currencies in different countries, but you would find that every time you have a different currency, let's say you are a Zambian and then you have dollars, you cannot go to a shop and transact using the dollars. You have to convert them to Zambian kwacha. And that is the same for International System of Units. If my unit standard is kg, that is for mass, then I find using pounds. For example, I have 200 pounds. I need to convert this to kg because this is the internationally accepted standard of the units. So what do you need to know under this topic? So by the end of this lesson, you must be able to understand what a physical quantity is. You must be able to differentiate what are known as base quantities and derived quantities. So if you are able to understand these 2 points under this topic, these are our objectives, then you have been able to grasp everything in this video. So let us get into the video. Now we start with the term physical quantity. Now, a quantity by definition, or the word quantity, simply means how much of something there is. And then physical quantity simply means measurable observations that are taken from an object or a person or anything. So by definition, a physical quantity is a measurable observation on an object. What do I mean? If you want to know how heavy you are, you go and measure your weight. If you want to know the duration of something, you go and measure time. If you want to find out how long something is, you are going to measure its length. So anything that you can measure and find out the quantity in numbers, that is what we refer to as a physical quantity, a measurable observation on an object. So that means that it can be anything. You can have weight, time, length, mass, etc. Now, when scientists were discovering this international system of units, they started with the simple 7 units, which are referred to as the base units. So this type of units do not need any combination to exist. They exist on their own. But before we move on to that, let us give the definition of a physical quantity. So a physical quantity is a measurable observation on an object. So this gives the definition, and the first question in the objective has been answered. So now we move on to a base and a derived unit and quantity. So we have what is called a unit and a quantity. So since I've already explained to you what a quantity is, being a measurable observation, now in what units is it measured? Why we need to know the SI units in which it is measured is because there are different units you can use for the same quantity. So for the international system of units, you'd need to only have one unit. For example, if I'm looking at mass being my quantity here, can be measured in grams, can be measured in kilograms, it can also be measured in tons. So, since we need to know one unit that is internationally accepted, that is why we need to know the SI unit. So the SI unit for mass is always the kg, the kilogram. This is the basic SI unit for the quantity mass. So this is what is a unit and this is a quantity. Now, we said we look at the two, which is a base and a derived unit. Before we even go to what a derived unit is, let us understand base quantities. Base quantities, as I highlighted, are quantities which do not need any combination to exist. So by definition, it is a quantity that does not need any combination to exist. Now, why doesn't it need any combination to exist? This is because these were the first quantities to be discovered, and there are only 7 in physics. We have time, we have luminous intensity, we have current, we also have thermodynamic temperature, we have length, we have mass. So we have time, luminous intensity, electric current, thermodynamic temperature, length, mass, and the other one is let's see 1 2 3 4 5 6. So the other one will come as we continue. All right, so we have an amount of a substance. So these 7 are what are called the base quantities, or they do not need a combination to exist. They exist independently. Now, one thing you must understand here is that derived, from the word derived quantities are quantities that are obtained when you mix any of these 2 or 3 of these base quantities. Now I'm going to give you this table, so I need you to copy it down. This table will show you the base quantity and its SI unit and the symbol. So since we have 7 base units, 1, 2, 3, 4, 5, 6, 7. So put the base quantity. We have the base unit. Then we have the symbol. So firstly, we have time. Times SI unit or base unit is seconds. And that is why whenever we are performing any calculation as we proceed, we'll always be using seconds. If you are given a question and then the time is in hours or minutes, in physics you always convert it to seconds because these are the SI units. The symbol being S. Then we have electric current, which is measured in amps, presented as A. We have thermodynamic temperature. This is measured in kelvins. So the SI units for temperature are kelvins and not degrees Celsius. So we have kelvins. And then we have luminous intensity. Luminous intensity means light intensity. How bright is the light from the sun, from these planetary bodies? This is measured in candela, presented as CD. And then we have an amount of a substance. Amount of a substance is a definition of a mole. So amount of a substance is measured in SI units called moles. And in chemistry, when you are looking at the mole concept, you understand that a mole by definition is simply an amount of a substance. So here you can see the base unit is a mole, its symbol is mole, M-O-L, eliminating the E. And then we have length. Length is always measured in centimeters. That is why when you have a question that is in inches, meters, millimeters, in physics we always convert back to centimeters because these are the SI units or the base units. Then the symbol is cm. And then finally we have mass, which is measured in kilograms. The symbol being kg. So, from these SI units, that is where we are going to pick up from if we want to find out what derived unit or quantity forms. Remember, the word derived means it's gotten from somewhere. So the somewhere that is gotten from are the base units. When you combine, for example, mass, when you combine, for example, length, which is a centimeter, okay, we'll use a meter in this case. When you combine a meter and a second, you get meters per second, which is velocity. So velocity in that case becomes a derived unit or quantity because it's gotten when you have combined length, which is a base quantity, and time. So for derived units, the list is too big, but I'll just show you the basic ones, and then I'll give you a chart to show you most of them, because there's no chart necessarily that will have all the derived units, because you can get a lot of combinations here to be able to get another derived quantity. But of course, there are some basic derived quantities and units. So if you're trying to define what a derived unit is, you can just say it is a unit that is obtained when you multiply or divide two or more base units. And then a derived quantity is a quantity obtained when you multiply or divide two or more base quantities. So a quantity for a quantity and a unit for a unit. So let us look at 5 examples. Number 1, we have area. Area is measured in centimeters squared. We can see that this is a derived unit or quantity because this centimeter squared means that you multiplied centimeters times centimeters. So you obtained 2 base units and then you formed a derived unit. That is the SI unit for area. Also, we have acceleration. Acceleration is measured in meters per second squared. We can see here that we have obtained a meter, which is length, and combined it with a second, which is time, and obtained our derived quantity, which is acceleration. Then 3, you can also look at velocity itself or speed. Speed and velocity do not differ. They only differ in situations where you are looking at directions. Velocity, we attach direction to it, or speed, we do not attach direction to it. So velocity measured in meters per second can be another example of a derived quantity. The last example you can look at is force. Now we understand that force is measured in newtons. Newton, only being a unit that was introduced to respect the physicist Newton, who had a role in discovering this force. But it is a derived unit because we understand that if we are finding force from basic science that we learned, force is calculated as force is equal to mass times acceleration. And here we understand that mass is measured in kilograms, multiplied by acceleration, which is measured in meters per second squared. So these being the derived units of force. So these are the units for force, the derived units for force. In case you're asking to say, why is it Newton? We can also look at pressure as well. Pressure is measured in pascals. Pascal also being a scientist that had a role in discovering pressure, but instead pressure is a derived unit because pressure is calculated as P is equal to force over area. So you can see here that we've combined two units to obtain pressure, and that is why it is a derived unit. And by the way, pressure can be measured in different other units, but in physics, we use the pascals as the SI units. That is all for this video and understanding the introduction to physics. In the next video, we shall continue our study.